All right, the last part of this sample experiment that you're supposed to analyze is the analysis section. So this is to be done at the very end after you've already completed your graph. First question is, what is the correlation between fish population size and oxygen levels? So if you go over to your graph, which we have here, you can see that as the oxygen levels are increasing, we're also getting an increase in population sizes across the board, no matter which fish species it is. This is indicative of a direct relationship. And not only is it direct, but it's also positive since it's increasing. And I just said as oxygen levels increase, the fish populations are increasing as well. So that takes care of one. Number two, what is the correlation between water temperature and oxygen levels? This uses that other graph that was directly below the data table. And this is an important graph because it's going to allow you to tie together two ideas in the next question. And the EOC loves to make you go back and forth between multiple pieces of data and try to draw conclusions. So this question is asking about the relationship between oxygen and temperature, which is exactly what this graph shows. And you can see that as the temperature is increasing, the oxygen levels are decreasing, and that is something that we see. Oxygen is a gas, and as liquids increase in temperature, they cannot. The gases lose some solubility, so they can't dissolve as much gas into them as the liquid increases in temperature. So as the temperature of the water is increasing, the oxygen level is decreasing. So that is an inverse or indirect relationship. As temperature increases, oxygen decreases. The third one, correlation between water temperature and fish population. So now is whenever you have to draw a conclusion between two different pieces of data. We already know that as temperature is going up, oxygen is going down. And we also know that as oxygen goes up, fish population goes up. Well, the opposite is also true. As oxygen goes down, so if we go back this direction, as oxygen goes down, fish population is going down as well. So since increased temperature causes decreased oxygen, that also means that increased temperature causes decreased population size. So that is, again, an indirect or inverse relationship. And that's right here. So indirect or inverse, as temperature increases, the fish populations decrease. So being able to draw a conclusion between those two pieces of data ends up being important. Number 4 says, according to your data, what's the ideal temperature for the crappie? And here you would just want to look at how you get where you get the highest population size. And that is going to be when there is 600 parts per million of oxygen in the water. And then you would just want to cross-reference where that happens. That happens at 600 parts per million, happens at 55 degrees Fahrenheit, according to the data. So the answer there would be 55 degrees. Was your hypothesis supported? Mine was, because I said that as oxygen went up, fish populations would go up as well. This will be dependent on what exactly your hypothesis was and what it said. Next, what would you expect the population size of smallmouth bass to be if the water temperature were lowered to 45 degrees? This is a draw conclusion type question, and on the EOC, you'll most likely have multiple choice options, but in this one you didn't. So if we were looking, I already forgot which fish it was, smallmouth bass. Okay, so if you look at the smallmouth bass, at 55 degrees, we see a temperature, or we see a population of 48, and we're asking if we drive the temperature down even further, what would it be? It would need to be a higher number than 48. The other thing I noticed in this data is that the higher the oxygen level is, the faster the rate of increase up here at the top. So I went ahead and said it would be 58 due to the colder temperatures. And again, this is going to vary also depending on how you analyze that data, but it should be higher than whatever the highest that had been reported thus far was. And then the last one, should Bass Pro invest in the temperature control units? Because after all, that's what the company hired you to figure out. And the data would suggest that yes, regulating the temperatures would lead to more successful fish populations, which if that's their end goal, then they should definitely invest in those temperature control units. So that wraps up the analysis section of this lab.